Okay, guys. Did you try it? Are you still trying to go back and look and see what you were supposed to be doing? Okay, so we did example 2, A, B, C. Looking at D, cosine of 240 degrees. What can you tell me about 240 degrees?
Quadrant 3.
Okay, quadrant 3. It's going to be past 180 and before 270. Okay, so if it's in quadrant 3, past 180, before 270, okay, which it's one that's actually on here, isn't it? So whether that helps or, whether you need that or not, but it's okay. In order to do the cosine of 240, now, is 241 that's on my reference chart? It's not on my chart. So we need to know the reference angle. So if you recall, we need to know how far is 240 degrees from the x-axis. Okay, so where is it closest to on the x-axis? 240 is closest to 180, correct?
Yeah.
So if 240 is closest to 180, how do I find the reference angle to get me started? We're going to subtract. We're going to do 240 minus 180. And so if I do 240 minus 180, I'm going to get 60 degrees. So that means we are now thinking about cosine of 60 degrees. And then we know it's in quadrant 3. I will zoom in here some because I'm realizing I'm kind of far out and it's hard to see probably. So, cosine of 60. Flip back to your chart if you need to, right? So cosine of 60. What was cosine of 60 according to our chart? Cosine of 60 is? One half, right? Cosine 60 is 1/2. So here we're going to say 1/2. What do we know in quadrant 3? What? It's going to be negative. All students take. Take, T stands for tangent. So tangent is positive, your others are negative. And so this is a negative 1/2. No, because then you would have gotten 30 and you would have been doing the cosine of 30. You have to use the x-axis. A reference angle has to match up with the x-axis. 270 would be the y-axis. Easy mistake to make, common mistake. Right, you would get 30, but then you would be doing cosine of 30, which is a totally different number. So, okay. That one wasn't too bad, was it? Degrees always makes life better, right? So now, with that all done, let's try to eat. Okay. Sorry, I had too much fun saying that, didn't I? Cotangent of 19 pi over 6. What are your thoughts about 19 pi over 6? Okay? It's big, isn't it? That's what I like to say. It's big. Because 19 pi over 6 is bigger than what's once around the circle? 2 pi. So in order to figure out, to get it so we can work with it, what do we do with this 19 pi over 6? Okay, we're going to subtract 2 pi. So in order to subtract 2 pi, well, think of 2 as a fraction. It's 2 over 1, right? But we need that denominator to be 6. So that means you multiply the 2 by 6, and it is 12 pi over 6. What is 19 pi over 6 minus 12 pi over 6? 7 pi over 6. Is that more workable? It's not huge anymore, right? Now, can you visualize? I would say without looking at your unit circle, some of you have already looked at the unit circle, I know, but can you visualize where 7 pi over 6 is? Okay, so like if we remember that this is 0, over here is pi, and back over here is 2 pi, right? What are those in terms, if we're trying to figure out where 7 pi over 6 is, what are these in terms of 6's? Yeah, 1 pi, right, is the same as 6 pi over 6. So this is 6 pi over 6. What's 2 pi? Yeah, if you take 2 pi over 1, it is 12 pi over 6. So now, does that help you know where 7 pi over 6 is? That's what I want you thinking about, right? 7 pi over 6 is going to be where? Yeah, over here in quadrant 3, just past 6 pi over 6. Yes, I know, you can grab your unit circle and a lot quicker just look and say, oh, it's there. But you don't always have the unit circle. And that's why I'm trying to give you tools of, okay, how do I figure out which quadrant this is in? So it is in quadrant 3. Now, 7 pi over 6, that's not one of my 3 on my chart. How do I find the reference angle for 7 pi over 6? Yeah, I want to know how far is 7 pi over 6 from the x-axis. And so in order to do that, we're going to do 7 pi over 6 minus 6 pi over 6. And I'll actually write that on the paper. What is 7 pi over 6 minus 6 pi over 6? Okay. 7 pi over 6 minus 6 pi over 6 is 1 pi over 6. Is 1 pi over 6 on our chart? Yeah. We have pi over 6, pi over 4, pi over 3. So that's one that's on our chart. So we are now thinking the cotangent of pi over 6, except we decide we're in what? We're in quadrant 3. Now, what do you know about cotangent? It's the reciprocal of tangent. So really we're going to be doing the reciprocal of tangent of pi over 6 in quadrant 3. Is tangent of pi over 6 on your chart? Okay, tangent, pi over 6. Tangent of pi over 6 is square root of 3 over 3, or 1 over square root of 3, right? What do we know about cotangent? It's the reciprocal. So since we want cotangent, what are we going to say? Square root of 3 is the reciprocal. Because 1 over square root of 3, you flip it, we get square root of 3. And last question always is positive or negative? We decided this was in quadrant 3, right? All students take. Tangent is positive, so tangent and cotangent are positive. So positive square root of 3. You're not giving up on radians, are you? You're going to keep trying them, right? I need you to, I really do. I'm like going uphill there, aren't I? Okay. One more here before we move to the bottom section. Cosecant of 495 degrees. What do you know about 495 degrees? Okay, it's big, right? That's what I'm going to keep saying. It's big. And when I say it's big, that means it's more than 360 or 2 pi. So how do I make it not big? Okay, right now it's past 360. So we're going to subtract 360 to get a more workable number. 495 minus 360 is? Yes, 135. 135? No longer big. That is on the unit circle, right? So the key is, though, is 135 one of them on our chart? No. What quadrant is 135 going to be in? Why quadrant 2? Okay, good. That's what I like you guys thinking. Don't just rely on looking at the unit circle, but it's past 90 before 180. So that puts it in quadrant 2. Okay. Now, it is in quadrant 2. So if it's in quadrant 2, where is it closest to the x-axis? In other words, how do I find my reference angle? Yeah, it's over there closer to 180. So this time I'm going to do 180 minus 135. And 180 minus 135 is 45. So we're going to be finding the cosecant of 45 degrees. What do we know about cosecant, though? It's the reciprocal of sine. So what I'm really going to do when I look at my chart is I'm going to look at the sine of 45 degrees, and then I'm going to flip it. Okay, you got your chart? Sine of 45 degrees is? Yeah, we usually say square root of 2 over 2, but 1 over square root of 2 is good here because we really don't need sine, though. We need cosecant, and cosecant's a reciprocal, so the reciprocal of 1 over square root of 2 is square root of 2 over 1, or in other words, square root of 2. And positive or negative? Positive because it's in quadrant 2, all students. Students is S, which is sine, and so this is another positive answer. Okay. You guys got the idea on those? Okay. You have something multiple choice at the beginning of the homework. I don't remember exactly what it is, but like
about like the terminal side or whatever.
Okay. Yeah. But one of your first major sections after that is doing this. They'll give you random angles. You have to be able to figure out, okay, what reference angle do I use? What quadrant is it in? And go from there. Okay. This is a big deal, guys. This continues through pre-calculus, through calculus, any type, or through trig, I guess, you know. Anytime you're using trig, this is important stuff. Now, before we move into the bottom section, some notes here. All of these angles that we just worked with, they either fell in quadrant 1, quadrant 2, quadrant 3, or quadrant 4. Notice what it talks about next. Angles whose terminal sides lie along one of the coordinate axes are called quadrantal angles. So now, instead of our angle line landing in one of the quadrants, we're going to have angles that are on 90, 180, 270, 360. Okay, so they're going to be those right or straight angles. Now, they do not produce reference angles. We did this, what, last week was it? And I talked about the phantom triangle that we had to draw. You know, we drew a triangle. It was a physical triangle, but I put a side length of 0 on it, which it was kind of confusing, but it also helped. It worked, right? Well, how do we do those without having to draw phantom triangles? That's what we're going to look at today. And so, okay, so in an ordered pair on the unit circle, so when the radius is 1, the x value is the cosine value. Someone asked me at one point why I have cosine and sine on my unit circle. And I said, we'll talk about it later. It's later. Okay, and I don't know which class someone asked me, but someone asked me. So the x value in the ordered pair is always the cosine value. The y value in the ordered pair is always the sine value. And all of our trig functions can be found based on cosine and sine there. Okay? So if I put my unit circle up here for a moment, on my unit circle, I'm trying to get zoomed out enough. This is the unit circle I provided you guys, right? It says cosine here. Why does it say cosine by the x-axis? Because it's the x value, right? The x value is the cosine value. Why did I put sine up here at the top of the y-axis? Because the y value is the sine value. So if you're looking at an ordered pair, the x value is the cosine value, the y value is the sine value. Now, you will notice I kind of put an ordered pair here. I wrote this on. You're welcome to do the same. Just kind of wrote it as a reminder that an ordered pair is cosine, comma, sine. Okay? So, for instance, if we're looking at 0 degrees, well, on a unit circle, 0 degrees is moving over here at the right, yes? So if you think about an ordered pair, to get over here, that is moving 1 right and 0 up or down, yes? So the ordered pair representing here at 0 degrees is 1, comma 0. Well, what did we just say? The x value is the cosine value. The y value is the sine value. So if you were asked for the cosine of 0 degrees, the cosine of 0 degrees is that 1 from the ordered pair. The sine of 0 degrees is that 0 in the ordered pair, because cosine is x, sine is y. We can do the same thing in all these quadrant angles. If we look at 90 degrees, well, 90 degrees would be not moving left or right, so an x value of 0 and then moving up 1. So the ordered pair representing 90 degrees is 0, 1. So what would the cosine of 90 degrees be? The x value of 0. And what's the sine of 90 degrees being? The y value of 1. Okay, you see how I'm doing that? Okay, we can do the same thing over here at 180 or pi. You move left 1, up or down 0. So cosine of negative 1, sine of 0. You can do the same thing down here at 270. Left or right 0, down 1. So that's the ordered pair, 0, negative 1. So cosine 0, sine negative 1. And then obviously back to 2 pi is the same as 0. Does that make a little sense? Okay, if you can remember that cosine, sine, that is definitely helpful. Now, those are the ones I'm focusing on today. Did you guys notice there's ordered pairs all around this circle now? And I've kind of ignored those other ordered pairs, haven't I? But if you look at those ordered pairs, do those numbers look familiar? This square root of 3 over 2, 1/2, square root of 2 over 2. Aren't those all numbers that are on that chart you're memorizing? Those are all numbers that we keep using. Well, what did we just say? The x value is the cosine. The y value is the sine. Well, check it out on your chart. What is the cosine of 30 degrees? Square root of 3 over 2. What is the sine of 30 degrees? 1/2. Okay, the chart's still good. I'm still going to usually go to the chart, but that's what these x values are. Those are the cosine, sine values right there. Okay, you'll notice in quadrant 1, all of my cosine and sine values are positive, yes? Quadrant 2, Well, you move left and you go up. So notice all of my x values are negative. Well, the x values represent cosine. So cosine should be negative in quadrant 2, right? My y values are my sine values. And sine values should be positive. If you look over here at quadrant 4, notice my x's, my cosines are positive. My sines are negative, as they should be. And if you go over here to quadrant 3, notice cosine and sine are negative, right? Because the positive one down here is tangent. Now, with that note, okay, you see the little bubble off to the right, or the cloud. So, in an ordered pair, notice it's x, comma, y. Or, what did I just say? In an ordered pair, it's always cosine, comma, sine. Just reminding you there, sine is your y value, cosine is your x value, and what's it say about tangent? Tangent is y divided by x. So if you have that ordered pair, take the y value divided by the x value, and that will give you your tangent value. And so if you think about it over here on the unit circle that I had up, down in quadrant 3, they were both negative, right? So a negative y divided by a negative x is going to result in a positive value. And what's supposed to be positive down in this quadrant? Tangent. Okay, so that's a good relationship to know there. Okay, so hold the thoughts on that bubble. Let's try one of these. It asks us to find the sine of negative 270 degrees. Can you visualize where negative 270 degrees is? I'm going to just put a little tiny graph next to each of these. Sadie says it's up at the 90 degree mark. Because what do we do to get to negative 270? You go where? Go, actually, clockwise. So if I'm going this way, here's negative 90, negative 180, and negative 270, yes? You can also think, where would positive 270 is down below, yes? So the negative is opposite. If you don't like moving in that negative direction, what could I add to negative 270 to show myself? Yeah, we could add 360. Okay, remember that negative 270 plus 360 is 90. So really, we are doing the sine of 90 degrees. What do we talk about with sine? It's the what value? The y value. And if we're looking straight up here at 90, what's the ordered pair that represents? 0, 1. Left to right, 0, up 1. So what is the sine of 90? It's what? 1. The cosine is 0. I'm not asking that though. And the sine is 1. So the sine of 90 degrees is 1. Questions on that? Maybe we're going to repeat the process on other problems, but are we okay with that first one? Okay. Tangent of 3 pi. Well, I'm going to say it. 3 pi is big, right? And some of you already know, oh, I know where 3 pi is. Perfect, great. For the rest of us. What if I just know 3 pi is big? How do I get it less big? We're going to subtract 2 pi off of it, right? And if we do 3 pi, and we subtract 2 pi, where are we at? Pi. That's better, isn't it? Tangent of pi. So where is pi? Where is pi? 180. Yeah. You're allowed to reference when I ask where is pi, it's 180. You're allowed to reference that. I want us to work in radians, but we need to know equivalencies too. So what is my ordered pair over here at pi or 180? Left 1, up or down 0. So it's negative 1, 0. How do we talk about finding tangent? Okay, it's the y value over the x value, which in this case is 0 over negative 1. Don't leave it as 0 over negative 1. Tell me what that is. And that is 0. Okay. Not too bad, is it? I guess I say that, and then the next one has a fraction in it. So, but if it has a fraction in it, that kind of narrows it down to 2. I mean, this is either going to be pi over 2 or 3 pi over 2. So you've got a 50-50 shot at this point. But what am I going to say about 11 pi over 2? It's big. Okay? It's bigger than 2 pi. So, let's make it less big. Not great math words, but you get the idea here. Okay? And you might like these words better. So, if I'm going to make 11 pi over 2 so I can figure out where this thing is, I'm going to subtract off 2 pi. But what is 2 pi in terms of halves? It's 4 halves, right? Because if I want a denominator of 2, and so we're multiplying that 2 pi by 2, so I'm going to subtract off 4 pi over 2. What is 11 pi over 2 minus 4 pi over 2? Seven pi over 2?
Yeah, I did this math.
What do we know about 7 pi over 2? It's still big. Ethan's stealing my words back there. Okay, if it's still big, subtract another 2 pi value, which 2, in terms of a denominator of 2, is still 4 pi over 2. So what do you know about 7 pi over 2 minus 4 pi over 2? 3 pi over 2. Do we know where 3 pi over 2 is? That's where? Three pi over 2 is the same as 270. And this is another one, I mean, and think about it, guys, okay? So 3 pi over 2, if you're starting up here, over here is 1 pi, right? So where's 1.5 pi? It's down there at 270. Okay, so we're doing what? The secant of 3 pi over 2. Except we're not going to really talk secant, are we? Secant is reciprocal of cosine. So we're going to do the reciprocal of cosine. What's the ordered pair down here? Left to right 0, down 1. So we're using 0, negative 1. So the cosine value would be what? Cosine would be 0. But we don't want cosine, we want the reciprocal of cosine. What's the reciprocal of 0? Yeah, okay. So, and here's what I would say. If I say 0, what's 0 is a fraction? That's 0 over 1. And so if you have 0 over 1 as your fraction for 0, then when you flip it, the reciprocal of 0 over 1 is 1 over 0. And so the reciprocal of 0 is undefined. Because when you have that 0 in the denominator, it's undefined. We talked about this the other day, didn't we? When I'm asking you about reciprocals, and we're talking about 0, the reciprocal of 0 is undefined. The reciprocal of undefined is 0. Okay. You might like the next one better. Cosecant of 5 pi. Subtract 2 pi. You might remember, without doing any subtracting, where the odds always land. The odds are always going to land over at 1 pi, or 180. The evens are always going to land over at 2 pi or 0. But let's go back to the idea that 5 pi is big. So if I subtract off 2 pi, I'm now at 3 pi. 3 pi is still big because it's still bigger than 2 pi. So again, I'm going to subtract off 2 pi. 3 pi minus 2 pi is pi. All your odds, odd whole numbers, always land up at 1 pi. So let's see, what are we doing? We're doing the cosecant of pi. What's the reciprocal function of cosecant? Sine. So we're going to do the reciprocal of sine of pi. Okay, false alarm. And so, I think you guys already told me, didn't you? Where is pi? It's over at 180. What's my ordered pair over here? Left 1, up or down 0. So what do we know about the sign at pi? Sign is 0. 0 is a fraction if you want, 0 over 1. What's the reciprocal of 0? You can think 1 over 0 if you want, or you can just go straight to undefined. Okay, guess they're not hanging up on me this time. Try the next one. Hello? Okay. I can. Okay. Bye. Mrs. Fernung needs you to do ISEP practice in her classroom, she said. I'm going to, my plan, if I'm like second hour, is to finish E and F. And then we might glance at the back, or we might have to be done. And then okay guys, so if I just finish E and F here, that takes you up through 42 on the homework. And what I told my morning class is, yes, go ahead and do that part of the homework for tomorrow. Now, I will still have at least part of the backside, if not all of the backside to finish, which is just 3 problems. That won't take very long tomorrow. So tomorrow, I'll finish notes. You could probably have some time to work on those problems that go with it. And we can also, the reason I want you to go ahead and do the first part of the homework is so we can go over some questions together. Okay? And then my other hope is to kind of practice and prepare for the quiz. And the quiz we'll plan to do Friday at the start of class. Okay? Yeah, you should be able to do through 42. I think, whatever that end of that section is, I think it's 42. Okay. That was for the benefit of Sadie, who was leaving. Okay. Did you guys try E at all?
I looked at it and then I got scared, so I stopped.
No, we're not allowed to get scared and stop. That's not allowed. Okay. Cosine of negative 3 pi over 2. Now, maybe you have to add something to this to figure it out, because when I see a negative, I'm not going to say it's big. I'm going to say it's small, right? But you don't necessarily have to. Can you visualize where negative 3 pi over 2 is going to go? Yeah, if I go negative 3 pi over 2, there's negative pi. Negative 3 pi over 2 puts me basically up at, I should be good and say up at pi over 2. You guys are going to say up at 90, as long as you have the location. Now, if you're thinking, yeah, I don't visualize that quite well enough yet, Well, when something's too big, we subtract 2 pi. If something's too small, we're going to add 2 pi. So you could have done negative 3 pi over 2 and added 2 pi, which is 4 pi over 2. Okay, so we're adding 4 pi over 2. And negative 3 pi over 2 plus 4 pi over 2 just so happens to be. So my point is, you don't necessarily have to add or subtract something sometimes, right? You can figure it out without that. But if you're at all confused, that's what I'm going to have you do. So we're doing the cosine of pi over 2. Well, what's the ordered pair up here at 90 degrees? 0, 1. Left to right, 0, up 1. And so what's the cosine of pi over 2? The x value, which is 0. Okay. One last one in this section. Can you visualize where negative pi over 2 is? Negative pi over 2 means I'm going to go down, right? If I go negative pi over 2, that's going to put me down at basically 270. Or if we want to be proper, we can say 3 pi over 2. I'm fine with 270. That's good. Okay, I'm just trying to, the more I say these numbers and equivalate them, I'm hoping they would start sticking in your head. That's my hope. Okay, now, if you don't like the fact that I just drew that on there, take negative pi over 2 and, as always, add 2 pi, which is 4 pi over 2. Negative pi over 2 plus 4 pi over 2, surprise, surprise, 3 pi over 2. So I'm doing the cotangent of 3 pi over 2. But instead of cotangent, what we're really going to do the reciprocal of tangent.
If we were to skip the step of just like rewriting it as a reciprocal, that's okay, like on the actual test. Okay, I just gotta make sure.
What's the ordered pair down here? Left to right, 0, down 1. So 0, negative 1. So what do we know about tangent? Tangent is y over x. So negative 1 over 0. But we really need cotangent, so cotangent is, instead of being y over x, is going to be x over y, which is 0. Okay. And I am ending about where I expected. Okay. Overall, the entire homework for this lesson is, oh, that didn't work, page 347, 21 through 48. Now, I still have not done the problems on the back. Since I have not done the problems on the back, I believe you can only do through 42. I am asking you to go ahead and do this for tomorrow. Now, whether we actually check the whole thing or not, it will just depend how the day goes. Okay? But I'd like to expect to see you to have 40 up through 42 done, and that way, as time allows, we can at least go ahead and start getting your questions in those front top sections. Okay? So that is my plan. Quiz, we're going to be Friday. Virtual kiddos, I have questions for you here in a moment. But I will finish those 3 examples in the notes tomorrow.